Right, now for number 5a, guys, we've got the following question. It says, solve the equation z squared minus 2pi z minus q equals 0, where p and q are real constants. Right, so, situation like this, and we're just going to use the quadratic formula. Right, and that's just going to give us the answer we need here. Yeah, no, don't need to go into too much and make this more complicated than it needs to be. So z, that's going to equal to 2pi plus minus negative 2pi squared minus 4ac, right, 2a. Okay, which means we get and we can therefore simplify this, can't we? We can simplify it down to pi plus minus p squared I squared plus q. Okay, which means that z is going to equal pi plus minus q minus p squared. Okay, so this question is just a case of plugging it into the quadratic formula and simplifying it. Another values we can get here. Alright guys, now for number b, it says, in an Argand diagram with origin O, the roots of this equation are represented by the distinct points a and b. Okay, and it says that given that a and b lie on the imaginary axis, find a relationship between p and q. Now remember what p and q represent, or at least what z represents here in terms of the roots. So these are our roots. Okay, so our roots, okay, are either pi plus q minus p squared or pi minus q minus p squared. Okay, now if you think about this in terms of what is an imaginary number, right? So an imaginary number, okay, for instance, square root of -1, usually that is unacceptable in the real axis. Okay, but it's acceptable in imaginary axis. Okay, and given that a and b lie on the imaginary axis and the roots are represented by the distinct points a and b, therefore that implies that q minus p squared, or at least the roots, must be acceptable in the imaginary axis, which means that q minus p squared, okay, is going to be negative, okay, because that's how we get to the imaginary axis, right? So if a and b are purely imaginary, therefore p, what was it? Q, don't want to put p there. Yeah, q minus p squared. Okay, q minus p squared is also going to be imaginary, which means therefore that q minus p squared is smaller than 0, which means that q is smaller than p squared. Alright guys, now for number c, it says, given instead that triangle OAB is equilateral, express q in terms of p. Right? So OAB forms an equilateral triangle. what does that mean? Well, remember what an equilateral triangle looks like. Okay, an equilateral triangle is always going to have angles of 60 degrees. Okay, it's always going to have angles of 60 degrees. So therefore I can say that as OAB forms an equilateral triangle, okay, I can say that the argument of Z, right, is going to equal plus minus 60 degrees, right? Z here, the argument of it is going to equal plus minus 60 degrees. That makes sense so far. Now, we can say, well, okay, where do we go from here? Well, if we think about this, okay, if we think about this in terms of a right angle triangle quickly, okay. Actually, no, sorry, not a right angle triangle. If we think about what the argument is, okay, we know that tan plus minus 60 degrees is going to equal P over Q minus P squared. Alright, we know that. Okay, our imaginary axis and real, not really a real axis, but for argument's sake here. Okay. And so what that means is that P over Q minus P squared is going to equal plus minus root 3. Okay. And so from here, we can say, well, P squared over Q minus P squared is going to equal 3, 2. Right? Which means that P squared is going to equal 3 Q minus P squared. Right, so P squared therefore equals 3Q minus 3P squared, which means that 4P squared is going to equal 3Q. Right, which means that therefore Q is going to equal 4 over 3P squared. Okay? And that's going to be your final answer for that question. Again, they're trying to trick you out. This is very much a understanding type of question. So, OAB is equilateral. So we've got 60 degrees, 60 degrees, 60 degrees. Perfect. Right? And the argument of Z, which is our complex number here, is equal to 60 degrees. Okay, so therefore we've got 60, 60, 60. Okay, an argument obviously implies tan theta. So therefore, tan of plus minus 60 degrees is equal to P over Q root Q minus P squared. So this equals plus minus root 3, which gives us this in the end.